from Year 10 and Ivan from Year 11. So today they are going to present on maths, which is the real-life applications for some of the topics. So the topics which they were assigned would be differentiation and also geometric progression.
Okay. So my name is Ivan and I'm from Year 11. So good morning to every year students and lovely parents. So today I'll present about differentiation and their real-life applications. So for differentiation, let's brush up on what it is. So this is the general formula for differentiation, which is v over dx, x to the power of n. So to differentiate the value of n, you move down n, and then you minus the power of n. Now this may be very confusing with all the alphabets here, but if we substitute a number into n, let's make n into 2, you have x squared. So the differentiation of x squared will be 2x, 2 minus 1. And that will give us to 2x to the power of 1. And since anything with the power of 1 is basically just itself, it will be 2x. That will be the differentiation formula. So let's take a look at an example that some math students will face in their exams. So the length of an ice cube is decreasing at a constant rate of 5 centimeters per second. Find the rate of change of the cube's volume when the length of that ice cube is 20 centimeters. So the equation dt over dt is used to represent the rate of change, which is 5 centimeters per second. Now the volume, as we know, a cube has its size all the same. So it would just be itself multiplied by itself 3 times, giving it the t cube. Now, to find the rate of change, we use dv over dt. First, we have to differentiate the volume. And to do that, we move the 3, we move it down, it will give us 3t. And the 3, the power of 3 minus by 1 will give us square, giving us 3t squared. As you can see, to find the rate of change, we need to multiply the differentiated volume and the rate of change, giving us 3t squared times 5. And if we substitute the value of t, which is the length, being 20 centimeters, it will give us 3 multiplied by 20 squared times 5, giving us 6,000 centimeter cube per second. That is the rate of change of the cube. Now there are many, from this example you may not be able to understand what do we use differentiation for. Take a moment to think about what examples can you think of when you look at this example question. Now, differentiation is very helpful because it is essentially the calculation of the rate of change of a quantity. Now, you can use differentiation to find the maximum and minimum value. Why would you want to find the maximum or minimum value? You can use that to find the maximum or minimum value of an investment or the profit gain. You can also use differentiation to find the rate of change, for example, speed and acceleration. Or you can use it to find the rate of change, for example, the decay of a radioactive isotope. That is the industrial use and general practical real-life use of differentiation. Now I'll hand the mic over to ALYA, my junior. Would you like to share?
Good morning, my name is ALYA and I'm from the Year 10 Math class, and today I'm going to be presenting about the real-life applications of math, specifically with geometric progression. So geometric progression is the sequence where the numbers are either multiplied or divided by a fixed number, which is known as the common ratio. And these are some of the formulas that we use to calculate it. So the first one is the nth term one, which, like, if we want to calculate the 20th term, we would replace n with 20, and then sum to n terms and the sum to infinity. So this is a real-life example where we can use geometric progression. So the situation is the monthly salary of an employee is 2,100 ringgit. So if we need to find their salary in 8 years' time if they are given a 3% raise every year, and we round it off to the nearest ringgit. So this is how we can use geometric progression to solve it. If they are given a 3% raise each year, that means that the total will be 103% or 1.03. So if we use the nth term formula, A representing the first term and R representing the common ratio, we can let the first term be 2,100 and the common ratio be 1.03. And the n is 8 because we want to find the salary in 8 years' time. So we do 2,100 times 1.03 to the power of 7 because it's 8 minus 1, which will give you 2,582.75. When you round it off, it's 2,583 ringgit. Another example you can use it for is like, the situation is if you want to pay off debt, and you can decrease the amount of debt by 8% per year. So if at the start of your first year you have 30,000, how much debt will you have in year 9? And you round it off to the nearest dollar. So to use geometric progression, if you decrease your debt by 8% each year, your common ratio will be 92% because you're decreasing it by 8. So your common ratio will be 0.92. So you let your first term be 3,000, your common ratio is 0.92, and your n is 9 because you want to find it in 9 years. So 3,000 times 0.92 to the power of 8 is 15,396.566. When you round it off, it's $15,397. So you can use geometric progression in situations like this to find the amount of money for interest or debt and salary you can earn in a certain amount of years' time without calculating each year one by one. That's it. Thank you.
That was a wonderful application of additional math into real-life experiences. We are extremely proud of our students at Rafflesia International School, Kajang. They were able to apply what they have learned in the classrooms into real-life applications, such as decreasing your debt, increasing interest rates. Wow! This is what we do in the classroom. This is what your children are learning in the classroom and what they will be taking with them through their life journey. So we want to thank you, parents, for supporting our students in their education. We want to thank Ms. Rati for encouraging the students today. Thank you for the life lessons. And students, well done. What you have done, always apply it in your life. Thank you.